Okay, in our last video we discussed 5 kilowatt heat strips. This video we're going to discuss 8 kW heat strips, 8 kilowatt. Very similar to the 5 kW. You're going to have two sections of your strips. If we look at a set of heat strips that's pulled out of the unit, you'll see we have one section between here and here. We come in, and then the entire element is energized. We have the same thing, it's redundant over here. We have one sequencer, okay? Remember, a 2-pole time delay thermal disk relay. All right, they're using that relay here. We have our lugs for L1 and L2. We have our limit switch, which these open at 165 degrees. They close at 40 degrees Fahrenheit. There's two of them, one for each strip. You see all the ceramic pieces here. You see the devices as we covered in our last video. If you look at this section here, you'll see that there are two prongs there. When you're looking at that, that's a fusible link. What you can see is if I wanted to test this, I could take a meter and put it on continuity simply and just put one lead here, take the other lead and put it here and see if it's open or closed. And we'll cover in our video how to do that with volts, because we don't expect you to unwire it or your whole thing of heat strips and see if you have continuity or no continuity for open and closed circuits. So very important to understand how to put your meter on volts and how to test that out. On the back side, you can see that as we used this set of heat strips in our last video, one of my fusible links is open, whereas the other fusible link is closed. So in this situation, my top element, my top heater, which is 50% of the heating capacity of this element, that top heat strip will not work. So we don't want to misdiagnose and say, hey, you know, the heating element needs to be replaced if the whole thing is simply just defected by one component. So very important to know how to troubleshoot these. You know, you got to think about it when you're dealing with somebody's heat. You're dealing with somebody's life safety. You're dealing with you know, something that is a necessity. You know, not everybody's got a fireplace in their house. You can't just go cut a tree down and you know, create warmth. And so when we're dealing with somebody's comfort, you know, there's a little bit of wiggle room there. But when we're dealing with somebody's heat, that's a little bit more than comfort. We're talking life safety. So we got to take what we're telling our customers and what our problems are extremely seriously for the benefit of their well-being. So we have our plate, we have our L1 and L2 lugs there. We got our picture of our blower motor meter that we like to use, the SC40 field piece. That's what we use at Ideal Conditions. Our technicians always refer to these videos if they're in the field. We promote that. Obviously, we care about the industry. We're all the same. So it doesn't matter where you're at. If you're watching this video, hopefully it helps you at your company as well. So we're going to quickly go ahead and build both layers. Layer 1 will be the top element and layer 2 will be the bottom element with what I have on my toolbar. I'm going to try to be quick about this. However, just if you need to fast forward the video just a little bit, that's understandable, but you might miss something that I might say. At the end of the day, you know, I'm teaching this to you and you're watching this video, so we both have something in common there, right? We both have a goal. So we're here for a reason. I'm here because it needs to be known. You're watching this video because you need the help. So let's have a little bit of patience and we'll get through this as quick as possible. All right, I'm going to go ahead and put a limit switch up here, and we're going to go ahead and build the connectors. So these black lines will indicate power in and then power out, providing that the switch is closed, right? We're going to go ahead and do the ceramic pieces that'll be on the other side. And we're going to go ahead and put the connector in the center of that. That'll represent the bolt in the connector, okay? And then the bar that's connecting my connector to the limit switch is here. So basically, if I have power here and this switch is closed, then I'll have power all the way over here. I'm not going to draw the elements. You just pretend that the elements are there. And when I say elements, I'm referring to the back side of my heat strip plate, these elements. And then on the other side, I'm going to put another ceramic piece. I'm going to put another bolt. And I'm going to put this square over here, which is going to represent a fusible link. And then, of course, we're going to go ahead and connect it. I apologize. I'm going to go ahead and move these back and use, as I said, have a little bit of patience. I'm going to use red because red is going to indicate the other leg of power. And there we go. And so this would represent my top half. And we'll say this is our fusible link, FL, and this is our limit switch, LS. All right, and so that's one strip. Now all we're going to do is we're just going to duplicate that to get two strips. Let's see how fast we can go ahead and do that. And go ahead and move our limit switch over. Put another ceramic piece in there. There we go. All right, I'm gonna go ahead and add some tools. We'll move our devices over onto the limit switch for inlet and outlet. Go ahead and put the little bar there so we know that if our limit switch is closed, it's connected to that piece there. Which means all we have to do is land a wire here and land a wire there. And then we're going to do the same thing on the other side. Put another ceramic piece. We'll put another connector. We're going to put another fusible link. And then we'll go ahead and connect the two. And then we're going to go ahead and label everything. All right, fusible link, limit switch. Okay, so the only thing we're missing at this point would be a relay. So I'm going to have a little bit of fun with this, and I'm going to do this without a relay. Okay. If I said we have L1 and that came into the top, and I had L2 and that came into the bottom, and I wanted to wire this up, then simply we would come up and in parallel we would pigtail one side of the heat strips. That's giving us one leg of power to one side of our heat strips. Okay, we'll go over to red to indicate L1, and this will come over in a pigtail, and it will land on the other side. Now on this, there's always 230 volts of electricity on both sets. So what's going to turn it off? Nothing. Not unless you put a relay in there. But I wanted to do that just so you can simply understand. Take the relay out of the equation. If that's what's complicating things, just take it out. Let's just simply look at this. We have two different sections. We have a limit switch for each section. We have a fusible link for each section. And that's it. And in theory, if there is 230 volts of power between L1 and L2, then there's absolutely nothing on this diagram that I drew that indicates that this is going to turn off. And if you understand ladder form logic, if you understand any type of schematic when you're reading it, that's a language, it's universal around the world that tells us, hey, this is what the system is doing. And for me to draw that, and I'll just quickly do this on ladder form, we'll say we have, you know, L2, we have L1, and if we were to look at it this way, we're coming in, we're going through a limit switch, a fusible link. Okay, we're coming in again, we're going across a fusible link, and then we're going across a set of limit switches on the other side. I'm just going to say that's my limit switch. It's obviously closed. And we can say these are limit switches. These are fusible links. And then in the middle of all that, we have the elements. And if I were to look at this, then I'd have to say, well, what's going to turn this off? You know, it's just going to run all the time. That's the same thing as we have up here. So what we're looking for is some type of control. So we want to come in here and we want to break these, and you only have to break it on one side. That's it. So we'll put a break in there. All right, so now I know that it's open on the L1 side. So that means I always have power on L2. And that's pretty much all we're going to do. I'm going to leave this up here for a second just so we can kind of go over another layer. We didn't cover that in our 5 kW video because I said very simply, let's understand the anatomy. Let's don't convolute this thing with a bunch of other components, with a bunch of other information. It's already complicated enough only because it's not well understood, even though it's very simple. And I want you guys to understand this very simply. I'm going to take a 2-pole thermal disk time delay relay. We call it a sequencer. And we're going to go ahead and move it over to here. We'll go ahead and mount it. There we go. We'll go ahead and do it that way. And then we'll go ahead and break a leg of power. Let's see here. We want to come over and let's go ahead and just erase that second leg of power. And let's just go ahead and redraw it very simply. All right. I'm going to go ahead and switch this diagram up a little bit in a second. I'll show you why. It's going to be easier for me to come over, land the M1 and the M3 as my common going in, and then I can come out with M2 and my M4. And now I'm breaking across my relay. And to make that illustration over here accurate, I'm just going to go ahead and clean this up a little bit. Just bear with me. Remember, we're in this together. So we're going to come over and we're going to say, well, L1 just hits the limits, the fusible link and goes right to the element. And we're breaking the L2 side. So to make this diagram accurate, then we'll come over here with the L2 side and we'll say before the limit switches, there is a set of open contacts or thermal discon delay relay. It's not going to identify what type of relay. It's just going to identify that it's either normally open or it's normally closed. And we're going to come in and draw the other side of the ladder, and we're going to say that that is L2. And that would be a very simple way of demonstrating. If I were to see this, what does it mean? And now the only thing I need to know is, what is my voltage? Where am I looking at voltage-wise? How do I know where my volts is here? And how do I know where my volt is here? And how can I make the connection inside my brain, very simply? If we were to take our meter and put it on volts, alternating current, I'm going to hold 2 pins up. These are going to represent my leads, my red and my black. And I'm going to say, very quickly, we're going to go through this. If I have 24 volts on this relay, the relay should be closed. And if I don't have 24 volts on a relay, the relay should be open. So I'm going to go over where my voltage is going to be present, what I'm going to have based on both open and closed. To begin with, power coming in, I'm reading 230 volts. And I'm not going to use ground anywhere on the cabinet because it's not going to tell me anything if I'm trying to troubleshoot. But if I wanted to just say, is there power there? Then I would say, I'm going to put one lead on this lug up here for L1 or L2, and I'm going to touch the cabinet. I'm going to read half of the 230, which would be 115. Now, if I put both leads on the same circuit, I'm going to read 0. All right? And for some reason, this confuses a lot of people. All right? But go ahead and take your meter out, go to any circuit, put them on the same lead, and you're not going to read anything. Doesn't mean there's no power there. So when I say 0 volts, as I said in the 5 KW video, when I go ahead and clarify that, doesn't mean that there's not voltage present. Very dangerous, so you don't touch nothing. So if you want to just say, hey, do I have power? Then probably going to come here and just come up the ground, and I'm going to test a second circuit and say, okay, yeah, there's voltage between both of these lines, and together I have 230. And so if I wanted to see if my limit switch, my fusible link was closed, then I would go on each side of the fusible link, and I would either read 0 or I would read 230 volts if my relay was calling and energized and I was closed across it. Now, if my relay is open, okay, then my path of electricity stops right here. There's no path back to here. All right, from this side. Matter of fact, we'll go ahead and use this green color to indicate. If the relay is open, the path stops. Let me go back to green. Excuse me. There we go. The path stops right here. And then over here, I'm going to go to red. The path here is going to go across my elements, right? However they're shaped. And it's going to come all the way back, and it's going to land right here. So my electricity that's coming on this side, my voltage here, is going to be the same over to here. So if I said, the relay is open, right? L2 stops. Theoretically, this is supposed to be L2, but I don't have L2 there. And the reason why I don't have L2 there is because the switch is open. It's not closed, right? So you have to have a little bit of understanding of electricity before you just go jumping into heat strips. So I'm the in-between of me talking to those that are a little bit ahead of their time, experience level. I want to dumb it down a little bit so you can understand this with that respect, but then also make sure that I'm still talking to guys that have been doing this for a little bit longer so that, they can follow the video and get what they need to get out of it. So in this application, if I'm open here, let's go back green. There we go. That's going to represent open. All right. If I were to do this, from now on, that's going to represent closed. Okay. So now we're open. So L2 stops. So if I were to take my meter out with this open, I'm going to read the sum of L1 plus L2, which means if it's 230 here, it's 230 here. And the reason why is because L1 is present all the way through back to here, and because my limit switch is closed, right? Because it's not 165 degrees in there if it's off. And it's going to come all the way back, and that means that L1 is now sitting on this side. So, granted I have L2 sitting on this side of the relay. With this relay open, L1 is now sitting on the other side, and it goes for the same on the bottom section. So this gets very confusing for people when they're trying to look at this, because no matter, if I were to put one lead on the cabinet or ground, no matter what I touch, I have power, right? If you were to take your leads and go, I'm going to put one on L1 with this relay in the open position, meaning it's not calling, right? Or if it's calling but the relay is just bad, then putting one lead on L1, I can sit there and go 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. See? But check this out. I'm going to go ahead and touch the cabinet. 115, 115, 115, 115, 115, 115, 115, 115, 115, 115, 115. 115 doesn't tell me anything. So, if I know that I'm reading 0 everywhere and that there is power, then I know I'm running the same leg of power all the way through, because this is 0, this is 230, this is 0, this is 230, right? If I kept one lead here, right, and I said, let me do the same thing to see if my relay is open, it's just as easy. I'm reading 0, 0, 0. The moment I go on the other side of this relay, I will read L1. So now, just like I read L2 and L1 here at 230, well, guess what? If this relay is open and I'm only breaking one leg of power, then all these are energized all the way back over here, and L1 is present on both sides of M4 and M2 on the relay. So across this relay, I will read 230 volts, the same as I'll read 230 volts here. All right. So it's very important to try to break this down as simple as possible. And like I said, it's not a complicated subject, but for some reason, it's just not widely understood. And I would love to clarify that, because I really love what we do. I love this trade. I think it's very special. And at the end of the day, if more people can sound the same, then I think that'll be more fair for customers and more fair for junior technicians that we're trying to teach too, right? So we're going to go ahead and close this relay. This relay is now closed. Well, what does that mean? All right. Well, that means that L1 is now no longer present on the other side. That means if I have L2 here and L2 here, now I have L2 here and L2 here. Now remember, I don't have any 24 volts yet. I'm not trying to throw that in here. You know, we don't need to be worried about W2 and common right now. Let's focus on the heat strips. The heat strips do not take 24 volts. What takes 24 volts is the relay, the bottom of the relay, to energize it, so your poles can actually connect across. We're not there yet. So if this relay is closed because it is calling, or it is closed because it's not calling and the relay has failed in the stuck closed position, which happens quite a lot, all right, then here's how I will know that. I don't want to say my heat strips are bad. No, just because they're running. All right. I want to sit here with my meter on volts alternating current, and I want to just simply check across it. Okay, I'm reading 0 volts on the top pole. On the bottom pole, I'm reading 0 volts. Does that mean there's no power? No, because I can do this. Oh, there's 115 there. Oh, there's 115. There's 115. There's 115. Doesn't tell me anything. Just tell me there's electricity. But I know this relay is closed if I'm reading 0 volts across it. because I'm L2 and L2, right? If you put both your leads on the same side, you're not going to read any difference. It's the same leg. So know how to understand that as simple as possible. I'll keep repeating it. Hopefully we get it. Limit switch. I'm closed if I read 0. Limit switch. I'm closed if I read 0. Right? And if I'm closed, then that means between here and here is now L2. Between here and here, I now have L2. So let's go ahead and look at what that looks like. Now L2 is here. There we go. Well, imagine that. We have L1 and we have L1. So now we have 230 volts and we have 230 volts. As long as the fusible links are closed and the limit switches are closed. And the moment I have a leg of power on each side of my strips, these strips will energize and you're going to have an amp draw. 8 kilowatt, typically your amp draw is going to be, say around 30 amps, 32 amps, right? If you're running just one strip, let's just say, for example, let's just say that this relay was closed on the top side but open on the bottom side, then what will happen is I will have bear with me. I will have L1 present all the way through. I will read L1 here, which means I'll read L1 here, which means I will read L1 there. All right. So if this relay has failed and I have one pole that's always energized, this happens a lot. There'll be sometime, probably in spring, where the customer's going to say, my light bills is super high. It's like $300. I don't understand why, because I'm not really running anything. And another thing, my unit never shuts off. The fan constantly runs. Technician's going to get out there and he's going to say, well, my fan won't shut off because I'm getting a W2 call. I'm sorry, I'm not getting a W2 call. My heat strip is energized. And if I took my meter and I read ampacity between L1 or L2, then simply I'm going to read, in this situation, 50%. All right, 50%. What that will look like, pretty much one of these is running at all times, right? We're going to cover a little bit this in a second, but this is, when you're looking at these legends, this is how it's supposed to look. You know, you're supposed to read this in its normal resting position. Basically, when the system is calling, the heat strips don't always run unless they're told to run, so I know it's under an open contact. So if I looked at this, I'm going to say, if I looked at this and I was foreign to it and I didn't know what I was doing, I'd say, oh wow, okay, this is pretty busy, it's interesting. All right, I'm going to refer back to my schematic. I see I've got links in here and limit switches in here. Okay, follow that. There's heating elements in between all that. Okay, I've got one relay, 2 poles that are supposed to be normally open. Okay, I'm getting half of, say, 32 amps, so I'm getting like 15, 16 amps of electricity that I'm measuring through current. Like, okay, and you know, it doesn't matter if I clamp it on L1 or if I clamp it on L2, I'm going to read the same. I'm going to get my meter out, 230, okay, all right, let's check this out. 0, 0, 0, 0, 230, 230, 230, okay. Between here and here, we're going to read L1 and L2, which is 230. When I come down to here, all right, I'm going to read 0. Come down to here, to the bottom strip, I'm reading 0. All right, so up here I'm getting 230, down here I'm getting 0. I got a 2-pole relay. Let's go back to the relay now. I'm reading 0 across the top because L2 is present all the way through. Okay, so I'm reading no change, so I'm going to read 0. On the bottom, I'm going to read 230. The reason why I'm going to read 230 is because L1, path of electricity, is present all the way back because the relay is in the open position. So again, I was able to quickly determine by looking at my schematic on how it's supposed to be, understanding the relay via experience, and just, you know, trying to one up my knowledge from the previous day, and looking at this here, I'm able to change out that component and simply save the day, get the customer some heat. All right. If I wanted to look at the, let's do this real quick. I'm going to open that back up. And we're going to change a couple other things here. Get rid of what's L1 and what's L2. And that's fine on this side. Okay. Let's go over here to our legend. All right. I have 230 volts. I have 0 volts because I'm on the same leg of power. Fusible links, anything on this side of the heating element, I'm going to read the same L1, so it's going to show 0 on my meter. Doesn't mean that there's no voltage. If I want to cross my heating element to this side of my limit switch, which is the L2 side, I'm still going to read L1. I'm going to still read L1 here. If my limit switch is in the closed position because it's not hot, all right, because it faults open, then on the other side of the limit switch, I'm going to still read L1. L1. Back to my relay, I'm still going to read L1 and L1. So you have to look at this very simply. L1 is present all the way up to the contact on both of these. And so you have to understand that if you understand path of electricity, that is the path of electricity. It stops where it's open. That means L2 is present on the other side. So I think a lot of the confusion is we get to this point and most people just aren't ready for that yet because their understanding of electricity, this isn't to shame anyone, they're just not there yet. Look, this is our industry. It's our job to protect it. It's our job to better ourselves and to teach what we do know, and what we don't know, it's our job to find out. That's what makes us technicians. We're not supposed to have all the answers. We're supposed to know how to find them and make sure that the answers that we do find are correct. Now, I don't like to edit any of my videos because I'm in a classroom environment. I'm teaching this. It is what it is. So if I misspeak or something like that, I apologize. I'll try to correct myself. Maybe throw a little description up on top on the video, something very simple. But you know, we need to get through this together with as much patience as possible, and your time is valuable, so I'll try to educate you as quickly as possible too, and not leave you with a ton of questions, because then I wouldn't really be doing my job very efficiently. I'm not going to talk about the motor, other than the fact that it does need to run every time this heat strip is running, and the fact that if it's not running, your limit switch, its job is to open on temperature rise. And I promise you, with these heating elements running, if there's no air moving across it, you're going to hit 165 degrees extremely quick. And so, now the bad thing about that is the limit switch, the moment it cools down, so if both limit switches kick out, both of them open, because I reached 165, then what happens is eventually it will cool down. It will cool down because the heating elements aren't running anymore, because we're already, we're in the off mode at that point. So let's just say our relay failed in the closed position, because these relays, they stick a lot. Sometimes you can just sit there and just give them a little pop and they'll open up. Replace it. Don't play with it. Replace it. So at the end of the day, if you're not getting voltage down here and this thing is closed, it's supposed to be in a normal open position. If it's closed, replace it. Don't sit there and try to do anybody a favor. Because the last thing you want is this limit switch to fail, you not have one. The last thing you want to do is bypass it by putting a jumper across it, because that's a big safety issue, because nothing else can turn this heating element off. It is there to do its job. It's there for a reason. So if this thing is constantly, I don't want to call it short cycle, because that refers to a compressor coming on and off, and it's off time and We'll get into other videos about how important that is. It's not a short cycle, but if this thing's sitting here cycling on and off, you know, every couple of minutes, guess what? Eventually it's going to fail too, right? Its job is not to constantly have to do that. If it's doing it for weeks on end, it might fail, and it can fail in the closed position, or it can fail in the open position. The best position to fail in will be the open position, because then it's as safe as it possibly can be. It's just not going to work. You don't want it to fail in the open position. And you do have a fusible link on my diagram. Fusible link in this case eventually will, the backside of it will just open up. It will eventually fall. But at the end of the day, you want to make sure that nobody's ever bypassing things on heat strips. All right. If you don't have a very good understanding on it, and nobody else in your organization can really help you, what's the worst thing you can do? You know, tell your customer that you know, they need to replace it, or you know, we just don't understand it. I mean, nobody wants to really admit that, but at the end of the day, you know, hopefully you can find these answers to your questions to give you the confidence and strength to do what's necessary. In this situation, if I had a bad relay, replace the relay. Say you don't have that relay. You can't sit here and go, oh my gosh, I don't have a 2-pole time delay thermal disc relay sequencer. What am I going to do? Oh my God, game over. No, just grab a contactor off your truck. Now, when we put contactors in place of these sequencers, you have to keep in mind the ampacity. If I'm running 32 amps of electricity with this relay fully energized, running 2 strips, then 32 amps is going to outperform any 30 amp resistant contactor. So maybe a 40 amp contactor or 50 amp contactor is what I'm going to have to do. So if you have contactors that carry a lesser load across the points, that's not going to work very well. It'll eventually hum, maybe chatter, maybe work for a little bit. It's going to get you back out there. They're going to have no heat again. So make sure that you're using you know, a strong enough contactor. So I'm going to go ahead and just redo my L2 side, and we're going to go ahead and wire that up. Let's see here. Let's see if I can get this. Nope, not going to work for me. So we'll go ahead and insert a image. I had my 5 KW video where I was having problems with my relay. Having a problem moving my relay out of there. It was very annoying, but I decided not to edit that out, because it is what it is. All right, so we're working with L2. All right, now my 5 KW video, you might refer back and say, oh man, he broke L1 and L2 with that contactor. I can't do that on an 8 kilowatt or a 10 kilowatt heater. I have to break one leg twice. So I'm going to pigtail off, right? Let me make that a little bit prettier for you. I'm going to pigtail off L2, and I'm going to hit both sides of my contactor, and then simply we're going to come out and we're going to land it on our limit switch. We're going to come out and we're going to land it on our limit switch. And that's simple as that. Contactor is energized. It's going to pull in. Most likely it's not going to stick, right? And everything's going to work fine. And this is very easy to do, and employ you guys to, you know, carry some extra contactors, especially if you still get confused on certain relays. Make sure you're not using like 9340 relays or 9380 relays. If you look on the side of it, it'll tell you what your full load amp you can handle across these points, and it's just not going to carry that load. So it's a big mistake if you try to do that. It's going to melt, for one. You will smell burnt wire, burnt plastic. Customer's not going to be very happy. It's going to create a mess. Pretty much everything in the cabinet's well listed, so I don't see there being anything beyond that. But you know, you never know. There might be paperwork up there that can ignite and catch fire. Hopefully not. So just be very careful. Make sure your work area, that's not just the area surrounding you. The work area is also the equipment and inside the equipment. Make sure you don't leave trash inside of it just because of that, because that trash is not UL listed. The cabinet is. So think about that, right? All right, so if I were to take these heat strips, okay, obviously here, my fusible links are on the right, my limit switch is on the left. On my diagram, my limit switches are on the right, and the fusible links are on the left. So just, and my lugs are obviously on the right, not the left. It really shouldn't matter. If you look at this sequencer, if I were to pull that out, I can easily put a contactor in here. You know, I don't have to put a sequencer back in there. I don't have to put a thermal disk time delay relay. And I'm sorry, I'm not going to keep saying thermal disk time delay relay because that's a mouthful. That's why we put nicknames on this stuff. So we're just going to say sequencer. All right. So we can put a contactor on there. 40 amps or higher. The bigger, the better. Doesn't hurt anything. The smaller, not good. And it's a simple fix. The customer's up and running, and we're good to go. Doesn't change a thing on the diagram. I'm still breaking L2, and you know, it's normally open. It's as simple as that, right? So now I told you I'm going to get into blowers running with this, and you know what makes that blower come on, and that's a lot of low voltage stuff. It's an extra relay, you know, at the end of the day, I don't want to make this any more complex of a video than it may already be. So I'm going to spare you that, and I'm going to do another video that's going to be 10 kilowatt. And I'll probably start the video off with something as simple as this image. It'll probably be a little shorter if you want to go to that video, and I'll just continue if you need that demonstration on how to make this blower run when you get a W2 call. A lot of these new units, they have modules on them. These modules have different speed taps, and you'll have a G call speed tap, which you select between medium, medium low, medium high, high or low, right? You're trying to gauge the CFMs based off of tonnage, extra dehumidification, whatever the case is, right? Manufacturer suggestion is always a medium speed or medium high speed, but you'll always see that when your heat strips energize, your X13 module will ramp up. That's because there's a white wire that comes down. It's actually landing on an internal relay inside that module that's dropping out the G call that's coming from the thermostat, and it's engaging that next speed. 'Cause you can't run two speeds at the same time. The motor will cook, right? So, but we'll get into that. This is just a permanent split capacitor motor. Permanent split because there's my capacitor. So there's no module on this. So I'm dumbing this thing down. I'm afraid we're getting into changing out more parts with the same parts, and we're starting to lose our technical ability in this industry. We're leaning too much on what's easy. We're leaning too much on, you know, I don't want to do that. That's too complicated. I don't understand it. And if it's not on the schematic, I can't do it at all. Listen, what was the manufacturer's intention? You know, stick with that. If it's 36,000 BTUs with an additional 30,000 BTUs of heat strips on top of that, and the manufacturer's intention is to run at 400 CFMs per ton, then all you got to do is make sure you have a motor that has the ability to ramp its speed up when it has an additional heat call. Now, at the end of the day, that doesn't mean that if you're running at one speed, say medium speed, 3-ton, 1200 CFMs, and I'm running a heat pump in addition with these, say I'm running 10 kilowatt heaters and then getting another 2.5 tons of heat out of it. So that heating capacity would be 2.5 plus 3, that's 5.5 tons of heat, 65,000 BTU, whatever it comes up to, doesn't really matter. At the end of the day, that additional heating capacity, it can still handle, you know, the RPMs on that motor, the CFMs, 1200 CFMs. It's not going to, you'll have a little bit warmer of a plenum, warmer supply air, some very good dehumidification there, right? So we're really drying that air out. However, that limit switch is not going to fault because you didn't get that speed right. That limit switch typically only going to fault when that motor's not running at all. And what happens is you'll have a lot of these modules fail. Somebody comes in and they're a little bit of a hero. You got to applaud them for that. They'll swap that motor out, put in a PSC motor. We call it a motor conversion. We do it a lot, and that's fine. But they never wire up the W2 call. So what happens is when that heating relay energizes, if they're not getting a G call, well, that motor's not going to run with it unless they hooked up W2 to run the blower relay anytime W2 was energized. And so your manufacturer, they know how important it is to run this motor with these heat strips. They've already put that safety in place. So if you're gonna do anything different, it's okay as long as you stick with the manufacturer's intentions. That way you're not deviating from what the manufacturer intended on what they wanted, right? Which sticks pretty close to, the diagram, the electrical diagram. So at the end of the day, if I start adding all these extra relays into here, I think that might make this a little confusing, probably as much as I sounded just a minute ago. So for the 8 kW auxiliary heat video, we're just going to kind of leave it at this. The one pole sequencer, not going to work. Why? Because if I put that there, I can only break one leg. The other one's going to run all the time. So I need to have a 2-pole here. On the 5 kilowatt, on that video, you'll see that I was able to break L1 and L2 on the same contactor. I didn't have to, I just chose to, right? And if that was the case, then I would have absolutely no voltage if that contactor was open. But here, I cannot do that. So I broke the L2 side. Now, if I wanted to break the L1 side, it's very simple. Just to do it real quick, it's not hard, and then I'll end on that note. We're going to go ahead and erase all these wires that we put on. There we go. Alright, so we got fusible link. We got limit switch. Alright, so looking at that, I wanted to come over. I can simply land on my limit switch. If it's closed, L2 will be present all the way back to here, right? And so I can break L1. Now, we picked my red color so it's less confusing. If I came over here and landed both sides of my contactor and broke it, it will look like that. So it's the same thing. Now the reason why I chose to break L2 versus L1 in my video is because which one looks a lot cleaner for you guys to see. I thought it looked a lot cleaner just, doing it the way we had it earlier, right? So we'll go ahead and just do that again very simply. And obviously we can't land wires this fast, but we can sit here and go there, okay, there, a lot cleaner. So don't think that, oh my gosh, I have to break L2 because he said break L2 and that's what it looked like in his diagram. Look, break one leg. Doesn't matter what it is. All right, just break it. At the other end of this thing, there's another way of doing this. I don't recommend it, but I'm gonna go ahead and do it for the video. Why not? It's fun doing this stuff anyways. Go ahead and get off the channel if you don't want to see any more. But if you're interested, why not? We can really have fun with this thing. So I can come over with L2 and say I'm gonna go ahead and break my bottom set, and I'm going to come up with L1. I'm sorry, I get to switch colors. I don't want to confuse you too much. I can come over with L1, right? And I can come over and say I'm going to break this top set. And then I can come back with L1 and say there's not going to be any change over here. And I can come back to L2 and say there's not going to be any change. I'm just going to take the long way around over to here. That's another way of doing it. Why? Why would you make it? That's not really cool. You know, I'm not trying to make a technician that might be coming in behind me one day confused. But if this is what you see and you don't want to change anything, it does work. So I'm going to go ahead and show you with my meter. All right. 230, 115, 230, 115, 230. Guess what? Guess what I'm going to have here? Nothing. Why? It's the same thing. Right? Right? Over here, what am I going to have? Nothing if the relay is closed. If it's open, I'm going to wind up reading L2. If my relay is closed here, I'm going to read nothing. If my relay is open, then I'm going to read 0. If my relay is closed, then we're going to read 0. So this becomes very confusing. If I were to look at it this way, relay open, that's pretty easy. I'm going to read pretty much, so it's even confusing if I'm trying to teach this thing. If I came over here and put one lead on the cabinet, I'm going to get 115. All right. If this is open, you have to ask yourself, why am I getting 115? It's because L2 is present as a path of electricity all the way back. So I'm reading L2 here. It's just too confusing. Don't do that to people. Will it work? Sure. Is it cool to do it that way? Absolutely not. So we don't end on that note. I think that'd be a little taboo. Let's go ahead and fix it the way it should be. And let's not try to have a whole lot of fun. Let's just simply take L2 and come into our relay. Let's come out of our relay and land our limit switch. Okay, and then we don't have to break anything on the other side. So we're just going to come over and take care of our fusible link without any contacts at all. So I hope this video helps you guys out. You know, I'm going to go ahead and jump into the 10 kW video and start talking about the fan motor, what amp draw I should be reading with that. And that's pretty much it. That video should be a lot shorter. And you know, if I have a X13 module, you know, obviously it's already wired up as a safety. But if I'm starting to do any kind of surgery here, yeah, that might mess some of those safeties up. So just be very careful with that.